A flight computer is a device that you're going to use to calculate essential information for your flight plan. At first, flight computers seem to be complicated pieces of equipment, but once you get the hang of them, they can be quite fast to work with. They come in two forms, the digital CX2 and the analog E6B, and are used primarily in the planning phases of flight, but also can be used in flight to make needed corrections. Each flight computer may be a little bit different, so refer to your device's manual for the specific steps of each function. Which one is better? Both of these flight computers can perform the needed calculations. The digital one allows you to simply fill in the blanks of the problem you are trying to solve and gives you an exact answer. The analog one requires you to rotate the instrument into the correct positions, which requires a good knowledge of the steps for each problem. The main difference is the digital one requires a battery, while the analog one will always work. The choice is yours. Let's look at a common scenario of flight planning that will utilize most of the functions of your flight computer. Let's say we are going to fly from point A to point B. Due to mountains in our route, we will choose to cruise at an altitude of 9,000 feet mean sea level. Our magnetic course will be 90 degrees, and our planned cruising speed will be 100 knots indicated airspeed. The pressure altitude for the cruise is 9,000 feet, and the winds aloft data shows a 25 knot wind from 120 degrees, with a temperature of 50 degrees Fahrenheit at that altitude. Our route covers 100 statute miles, and our aircraft holds 500 pounds of Jet A fuel at an average burn of 200 pounds per hour. Let's start with converting some numbers. First, we are going to use the analog E6B to convert statute miles to nautical miles. Find 100 on the inner scale marked statute miles and follow the arrow up, over, and down to the number presented as nautical miles. In this case, we see 100 statute miles is approximately equal to 87 nautical miles. Now, let's do the same calculation on the digital flight computer, or the CX2. Turn on the CX2, type 100 for the statute miles first, then press the second key, and then the statute mile to nautical mile key. We see the answer is approximately 87 nautical miles. Now let's convert the temperature given from Fahrenheit to Celsius. Looking down at the temperature conversion scale on the E6B, we find 50 degrees Fahrenheit. Opposite of that, we find 10 degrees Celsius. We will need this number for calculating density altitude and our true airspeed. Now let's do the same calculation on the digital flight computer. Type the Fahrenheit value first, 50, then press the second key and find the key with Fahrenheit to Celsius. We see the answer is 10 degrees Celsius. Now that we have these numbers converted to a scale easily used for aviation, let's find out what the aircraft's true airspeed is. Remember that true airspeed is calibrated airspeed corrected for pressure and temperature. It's our actual speed through the air and needed to ultimately determine our ground speed. So, if we are going to cruise at 100 knots indicated airspeed, what is our calibrated airspeed? Remember that we need to consult the calibrated airspeed chart in our POH to determine this value, which is indicated airspeed corrected for instrument and installation errors. Let's assume we've determined our calibrated airspeed to be 103 knots. In this window, we need to match our pressure altitude, 9,000 feet, with our temperature, 10 degrees Celsius. Now we need to find the calibrated airspeed, 103 knots, on this inner scale and look at the outer scale for the true airspeed. In this case, we see that 103 knots calibrated airspeed equals 120 knots true airspeed. Now let's do the same calculation on the CX2. First select the flight key, then select the airspeed menu using the arrow keys and the enter button, followed by the plan true airspeed section. Now we enter the calibrated airspeed of 103 and press enter. Type in the outside air temperature of 10 and press enter. Type in the pressure altitude of 9,000 and press enter. Now we see the result of 120 true airspeed. Now let's find out how the wind will affect our course and ground speed, which we will need to know to calculate our fuel requirements. We've checked the winds aloft forecast for the segment of the flight and found that the winds are from a true heading of 120 at a speed of 25 knots. Let's calculate our wind correction angle and ground speed using the E6B. First, we need to place the wind direction, 120, under the true index. Second, we'll place a mark for our wind velocity, 25, up from the center of the wheel. Third, rotate the wheel so the true course, 90, planned for our flight under the true index. Fourth, place the wind velocity mark to our true airspeed, 120, and we can read the ground speed of 98 under the center. Last, our wind correction angle is read between the center line and the wind velocity mark as 6 degrees right. This makes our true heading 96 degrees to follow a true course of 90 degrees due to the wind. Now let's calculate our wind correction angle and our ground speed on the CX2. First select the flight button, next select plan leg followed by heading ground speed. Enter our planned true course of 90 degrees and hit enter. Type 120 for our true airspeed and press enter. Type 120 for our wind's true direction and press enter. Type 25 for our wind speed and press enter to get the results. We see our true heading to be 96 degrees and our ground speed to be approximately 98 knots. Now we have two questions to answer. How long will this flight leg take and how much fuel will we need? Let's line up the inner scale triangle with the ground speed we calculated at 98 knots. Now, find the distance of 87 nautical miles on the outer scale and read the time on the inside as approximately 53 minutes. In this example, the aircraft burns 200 pounds per hour. We need to convert this to gallons for use with the E6B. Jet A weighs 6.8 pounds per gallon. So dividing 200 pounds by 6.8 pounds gets us 29.5 gallons per hour. Match the fuel burn triangle with a fuel rate of 29.5 on the outside scale. Then go to the minutes area to find 53 to see almost 26 gallons will be burned in flight. And again, we'll use the CX2 to find the same answers. Go to flight, plan leg, and then leg time. Enter 87 nautical miles for the distance, followed by 98 knots for the ground speed. Press enter and the answer is approximately 53 minutes. Now hit the back button to get to the flight menu and select fuel. Select fuel burn and enter the flight time, which we see is automatically populated from the last calculation, and enter the rate of 29.5 gallons per hour. The result is 26.2 or approximately 26 gallons that will be burned on that leg. There are many other functions available with the CX2 and the E6B. The best thing to do is to read the instruction manual and work with the computer on sample problems.